Have you ever wondered what makes the sun so hot and luminous? Our sun, that brilliant star at the heart of our solar system, is a celestial body of immense importance. Yet, it is shrouded in mysteries that have intrigued and puzzled scientists for centuries. The sun, a seemingly ordinary star compared to the billions of others in our galaxy, holds a special place in our lives. It's the source of all our daylight, the engine driving our weather, and the provider of the energy that fuels life on our planet. It's a beacon of warmth and light, a constant in our ever-changing world. But beyond its role in our day-to-day lives, the sun is a fascinating scientific subject. It's a living laboratory for studying stellar physics, a field that seeks to understand the life cycles of stars. It's also a key player in the cosmic drama of our solar system, influencing everything from the orbits of planets to the formation of comets and asteroids. Despite its familiarity, the sun holds many secrets. What is it made of? How does it generate its heat and light? How old is it? And what will happen when it dies? These are just a few of the questions that scientists are striving to answer. In our quest to understand the sun, we've sent spacecraft to study it up close, built sophisticated telescopes to observe it from afar, and developed complex computer models to simulate its behavior. Yet for all our efforts, the sun remains a tantalizing enigma. A closer look at the sun reveals a dynamic, ever-changing entity. It's a swirling mass of hot plasma, threaded with magnetic fields and punctuated by flares and sunspots. It's an object of immense power and beauty, a testament to the awe-inspiring complexity of the universe. Our journey into the heart of the sun is a journey into the heart of the cosmos. It's a quest for knowledge, a search for truth, and a celebration of the human spirit. It's a reminder of our place in the universe and our connection to the stars. To understand the sun better, let's delve into its birth and formation. The tale of the sun begins in a molecular cloud about 4.6 billion years ago. The elements of this story are not heroes or villains, but particles of dust and gas. Over time, gravity, the great sculptor of the cosmos, started pulling these particles together into a denser and denser clump. As this clump of dust and gas grew larger, it also began to spin. Due to the conservation of angular momentum, a principle we see in action when a spinning ice skater pulls in their arms and spins faster. This spinning, swirling mass eventually flattened into a disk with a hot, dense center. This center, or core, was the seed of our sun, a protostar. Now, you might be wondering, when does this protostar become a star? That's where the magic of nuclear fusion comes into play. In the core of this protostar, the pressure and temperature were rising, and when they reached a critical point, hydrogen atoms began to collide and merge, forming helium. This process, known as nuclear fusion, releases an incredible amount of energy in the form of light and heat. So imagine this: the protostar's core igniting, a new light kindling in the darkness of space. The energy from this fusion process pushed outward, balancing the inward pull of gravity. This equilibrium or balance of forces is what defines a star, and in that moment, our protostar graduated, transforming from a mere clump of dust and gas into a glowing sphere of gas and plasma. But this was no ordinary star. This was the sun, our sun, the heart of our solar system, the source of the light and warmth that has allowed life to flourish on Earth. And thus our sun was born, a fiery glowing sphere of gas and plasma. The sun is not just a fiery ball, it's a complex, dynamic system. A fascinating entity. It's composed of several layers, each playing a significant role in its overall function. At the heart of the sun lies the core, which is where all the magic happens. It's here that the process of nuclear fusion occurs. Hydrogen atoms combine to form helium, and in this process, a tremendous amount of energy is released. This energy is so immense that it keeps the sun burning bright and hot. Surrounding the core, we have the radiative zone. This is a region where energy created in the core moves outward in the form of light. It's a slow process. In fact, it takes thousands of years for the energy to travel from the core through this zone. Next, comes the convective zone. Here, the sun's energy in the form of heat gets carried up to the surface by the process of convection, similar to how hot air rises above a radiator. The sun surface, or the photosphere, is what we see when we look at the sun. It's where the light finally escapes into space, making the sun visible to us. It's a bubbling sea of plasma with temperatures around 5,700 degrees Celsius. Above the photosphere, we find the chromosphere and the corona. The chromosphere is a thin layer just above the photosphere, and the corona, which is visible during a total solar eclipse, extends far out into space. These layers are much hotter than the surface, a puzzling phenomenon scientists are still trying to understand. Energy created in the sun's core, traveling through various layers, finally reaches the surface. This journey, this dance of energy, makes the sun hot and luminous. The sun is not just a simple fiery ball, it's a star with a complex structure, a dynamic system that's in constant motion. It's this intricate structure and the nuclear fusion process that give the sun its heat and light. This is the sun, our star, the heart of our solar system. With our current technology, living on the sun is a far-fetched idea. The sun, as we know it, is an environment of extreme conditions, not fit for human habitation. It's a roiling, churning sphere of incandescent gas with surface temperatures reaching about 10,000 degrees Fahrenheit and a core that's about 15 million degrees. Imagine trying to survive in such a scorching environment. Not to mention, the sun doesn't have a solid surface like Earth. It's made up of hot plasma interwoven with magnetic fields. Essentially, there's no ground to stand on. And let's not forget the intense solar radiation. The sun emits high-energy particles and electromagnetic radiation that would be harmful, if not lethal, to humans and most known forms of life. These challenges make the sun an unlikely candidate for colonization or habitability. So, for now, living on the sun remains a fascinating but impossible dream. The sun, a fiery ball of gas and plasma, is more complex than it appears. Born from a nebulous cloud of dust and gas, it took millions of years to evolve into the radiant star we see today. Its formation, a complex process involving gravitational forces and nuclear fusion, resulted in a celestial body with an incredibly hot core and a surface temperature that far exceeds anything we can endure. The sun's unique characteristics, its size, temperature, and energy output make it the heart of our solar system. Yet, despite its importance, life on the sun is an impossibility. The extreme heat, intense radiation, and lack of a solid surface make it inhospitable, a place where life as we know it cannot exist. As we continue to explore and understand the cosmos, the sun remains a beacon of light and mystery, a star that's both familiar and enigmatic.